So let us look at a simple campus use case. You have a /30 from the upstream provider. The /30 is 164.10.0/30 as the point-to-point link. Then they have routed over that /30 100.64.10.64/28, which you can do whatever you want. So you have a border router in the diagram and you have a core router, and then you have a link to a switch which has the servers, which have your public services, as well as the links to the switches in the different campus buildings. So you will implement NAT, NAPT on the border router. The public services LAN will use public IP addresses block, and we shall use a /29, in this case 164.10.72/29 out of the /28 we've been given. Then the rest of the campus will use address space out of 192.168/16, which we shall NAT to 100.64.10.64/29. So let's look at how you'd do this on a Cisco. Typically, you would set the NAT configuration on the border router, and then you define the address range that you want to NAT using an IP access list. So you say IP access list extended and you give it the name, and then you have those statements, and you say deny that IP range. Now these are wildcard masks. 000255 is a wildcard mask. So this means so the first line is 164.10.0/24. You flip it because it's a wildcard mask. So deny from that /64 any, and deny the second deny rule says deny anything from 192.168 to 192.168 with a wildcard mask of a /16. Note that inside these access lists, a deny statement means do not NAT. It will still pass the packet, but it will just not NAT it. A permit statement means you will NAT this particular, whatever matches this particular statement, and then still pass the packet along. What we've said is we by this configuration is we are not going to NAT any of the public address space. We shall not NAT when the source and the destination are both internal, and we will NAT from an internal source to any other external destination, and anything which doesn't match any of these rules, which shouldn't exist, we will not NAT it, but we want to log it to see has somebody configured an address which should not exist on our network and is trying to send outgoing packets. That's what this rule set says. The next step is you have to define the internal and external interfaces that you want to NAT to or NAT from. The external interface, you put the IP address, which is the link to the ISP. Remember it, there's a /30 that they gave us, and IP NAT outside tells Cisco that this is the external interface. Then on the internal interface, we have a 192.168 IP address, and we say IP NAT inside to tell Cisco that this is the internal side of the network. Once you've done that, the next thing that you do, that you could do, is modify the timeouts, and we've shown you the different timeouts that are available. So there's a DNS timeout, ICMP timeout, UDP timeout, FIN RST timeout, and then the TCP timeout. DNS, ICMP, UDP, and FIN RST timeouts that we are showing on this slide are the Cisco defaults. But the TCP timeout, we've dropped it from 24 hours to just 1 hour to 3600 seconds. All of these timeouts are in seconds. So the timeout means if there is no traffic for that amount of time, then iOS will remove that translation entry. So if somebody wants so that port becomes available, that source and destination port becomes available. So there are lots of other translation timeout options in Cisco iOS, but the ones that people usually touch are these ones because most of your traffic is going to fall under one of these categories. So those are ones which you should look at possibly modifying. Now what we're going to do is the next statement will activate NAT on just one IP address, and we shall say IP NAT inside source list, the list, and then the interface is the particular interface, the outgoing interface, then overload. So this will match that NAT plus list that we remember that access list that we created, and we'll say it will be for traffic going from gigabit 02 out through gigabit 01 to the internet. Overload means use NAPT, so one-to-many mapping of TCP UDP ports. So all the campus traffic will appear as if it's originated from the 164.10.2 address, which was the /30 point-to-point. So that is one typical way of doing it. Now, what we could do is we could make this slightly better and activate NAT on an IP44 address pool. So first you have to create the address pool, IP NAT pool campus. You give it, we've just called it campus, and you give it a range of IP addresses, and then you tell it the prefix length of the address range it came out of. So you're saying from 64 up to 67, and prefix length /29, so that internally it knows that this was a /29. Note that we are able to use the 64 address, which ordinarily would have been the network address. So we've defined that we are going to have 4 public IP addresses out of that range that was given to the campus. Then you say, instead of using the interface as we did for the IPNAT command, you say IPNAT inside source list. You give it the list pool, and then you say campus for the pool that we've just created, and then overload as well for NAPT. To find out what's being translated, you do show IPNAT translations, and you will see different columns. You have the inside global, the inside local, the outside local, and the outside global. So the way to read this is the inside local address was trying to reach the outside local address on that port, and it was translated to the inside global address, and the outside part, the destination, is listed outside global. In this case, the outside global and outside local won't change. So those are UDP connections. So you have the local IP address and the port connecting to the external one, and then the global destination addresses and the ports.